Hello students. Today we are going to learn how to solve systems of equations by elimination. We have learned how to solve systems of equations by graphing and by substitution. So this will be a third way to solve systems of equation using elimination. Okay? This method is called elimination. By the way, we're on page 109.2a. This method is called elimination because, as the name implies, we are looking to eliminate a variable. In order to eliminate one variable, we need to have the same, so we want to put same, but opposite coefficients for one of our variables. For example, one might have negative 2x plus 3y equals 9. We would look to try and find something that might have 2x plus 4y equals 3. Something like that, we would add the 2. See, we're looking to get negative 2x and positive 2x so that when we add them together, those will be eliminated. Another example is if we had 3x minus 4y equals 10, and then we had 2x plus 4y equals 8. And in that case, we would add these together, and we would see that the 4 y's would be eliminated if we added the two equations together. So we've got 4 steps using elimination. Pick a variable, either x or y. Like this one is, I chose x because they were opposites, but they have the same variable. So negative 2x and positive 2x. Then the other one, here I would choose the 4 y's because they are the opposites. And if we add them together straight down, it would get rid of the y value. So again, pick a variable. Use algebraic properties to eliminate a selected variable. Add the two equations together and solve for the remaining variable. Now, I didn't really like these story problems, so we're going to get right into the algebra part of solving systems of equations by elimination. So I'm going to have you go to the next page. And we will still be using these same properties. Okay, so let's do some practice ones. So number 3 on page 101, I'm going to add these two together. See how this is x and negative x? So if I add them together, I can get rid of that. So then I'm going to add negative 1y and negative 6y, and I get negative 7y equals 2 minus 2 is 0. X minus x, that goes away, so it's eliminated. Now we simply solve for y and then plug 1 back in to see what our x value is. So if I divide by negative 7, y equals 0. Now if I plug that back in, we can say that x, I'm going to put it into the first one, minus y equals 2. So if y is 0, x minus 0 equals 2. So x equals 2. So then our solution on number 3 to the systems of equation would be 2, 0. Again, we want to put them in ordered pair form with our x listed first and then our y. Okay? All right. Now I'm going to go on to, I'm going to skip number 4 because that looks fairly easy. I'm going to jump all the way to number 6 over here. And hopefully you can still see that pretty good. Number 6, see how there's not an opposites? So what we can do is multiply one of the equations by something so that we can force it to have an opposite. So on number 6, I'm going to multiply each of these by a negative 1. And when I do that, I'm going to make a negative x, a minus 2y, and a negative 17. Do you see what that does? If I multiply each one of these by a negative 1, that just changes all the signs so that when we have a negative 2y and a positive 2y, our 2y's will be eliminated and we'll be left with just the x's, and then we can solve. So if we add those two together, negative 8x, these go away, equals negative 17 and negative 23 is negative 40. Okay. Now we solve for x by dividing by negative 8. And I'm getting a terrible glare, so I hope you can see it better than me. So if x is 5, we can go back to this top one before we multiplied by a negative 1, and we can say 5 plus 2y equals 17. Okay, if I subtract 5, I get 2y equals 12. Divide by 2, y equals 6. Okay, so then we write it in ordered pair form. So your solution would be 5, 6. And there's our solution. Okay. Next, I want to do another one for you. I think I'm going to jump and try number 7. Okay, so I see that they're already opposites, so I can go ahead and add straight down. Remember, if they weren't opposites, we can force them into being opposite. But here, if I add negative 2x and 2x, 0. 6y minus 6y, 0. Negative 15 plus 12, negative 3. Oh, so both variables are eliminated. What do we do then? Well, it's the same as when we were trying to solve for x and the x's disappeared. Does this form a true statement? 0 equals negative 3? No. If it doesn't, your answer is empty set, or you could write no solution. Okay? All right. All right, I think we've got a hold on it, students. Good job. Good luck. You rock.